Let's look at the last example problem in this topic, social distancing 3. So this time I want to try something new. I want to do live coding. So I'll try to code up the solution while I discuss my thinking process. So of course I've solved this problem before. So this is different from how I would approach a problem if it's the first time I'm seeing it. But still, I hope this will be this live coding will be of value to your learning experience. So here's the problem. So we have a little bit weird classroom that have a single row of n seats numbered from 0 to n minus 1. So you go into the classroom, some of the seats are already occupied. You want to find the seat. First, it's not adjacent to any other student. You want to keep some distance. But second, you also want to actually maximize your distance to the closest student. So of course, if it's in real life, you need to worry about what if other students come in and then sit close to you. So for simplicity, let's assume that you know you're the last person. So you enter at the last possible minute. So then you can pick a seat that's as far as possible from any other occupied seat. And this question asks you to compute the list of all seats that satisfy that condition. So let's first look at some example. So the n is the number of seats. So 1 represents the seat occupied, 0 represents the seats that's free. So of course, if we have these, then we can sit either here or here, and that will have a distance of 2 empty seats between either of these seats and the nearest occupied seat. So these are numbered starting from 0. So this is 0, 1, 2, 3. So we can sit at either 3 or 4. And if the whole room is empty, then we can sit at any of the seats, 0, 1, 2. And this one, we can sit at either end and be able to maintain a distance 3 from the nearest occupied. And this one, there's no way to sit anywhere without being adjacent to someone. So you're asked to basically you basically decide to leave. So you watch the lecture online. Okay. So for this one, there are 4 seats that have a distance of 1 empty seat between that seat and the nearest occupied seat. So seat 0, or seat 4 or 5, or the last seat 9. So yeah. So I think I don't think the other illustrate anything new. The other example. So let's write it up. So let's look at the parameter. It says n can be as big as 10 to the 6th. So that means we need to scan through the array. So linear time algorithm will be okay. So if we do something on the sort of n operation or something 10n operation, 50n operation, those are all kind of okay. But if we need to do n square operation, that will not be okay. And the reason is you probably heard the computer CPU are characterized by gigahertz. So like 2 gigahertz, 2.5 gigahertz or something. So a gig essentially is 10 to the 9. So then what that means is every second the CPU can perform about, if 2 gigahertz means can perform 2 times 10 to the 9 operations, roughly. So it has to be very simple operations. So that's sort of a kind of rule of thumb is if you calculate the kind of operation you need to perform, it's higher than 10 to the 8, then it's a little bit dangerous that it may not be efficient enough for this kind of a problem. But for this problem, it's I think linear time is pretty natural. I actually can think of a way of solving the problem somewhat naturally with higher running time. So anyway, we first need to store the data, the input data. But we don't have so first let's read in the n, the number of elements. So we talk about using vector to store, to sort of variable size array. Here I just want to show a different way of doing it. So we can declare a fixed size array when we know the maximum possible value. So because we know the maximum n is 1 million, so then we can just declare an array of this size. And here I use a Boolean type because it's essentially binary, either 1 or 0. So from my point of view, I can just view them as true or false. True means occupied, and false means it's not occupied. So then I have to read in the data. Yeah, so here I declare this variable outside the main function. So this is known as a global variable. So here, this variable a can be accessed anywhere in the program. So let's call it something else, because let's call it what? Let's call it seats. Okay, so we declare. Okay, so now we need to read in the data. Yeah, so actually using Boolean, one thing that's a little bit not nice is actually I cannot directly see into that. I have to sort of check based on this. So this is normally I would probably use either int or actually using char, which is can also be interpreted as integer, but it takes less memory than int. So we initialize the array, we read in the data to put in the value. Okay, so now we read in the data. What I want to do is I want to scan through these seeds, and I basically find the consecutive empty seats, and then I figure out if I see the person there, where would be what would be the distance. So let me just copy sort of one setting here, so that when I talk about, I can refer to this particular example. Let's change it slightly, just so that I can. Yeah, I think this is slightly more interesting in terms of discussing implementation. So I'm going to scan through this array and then find the non-empty. So then I will need the index that will scan through this array. So let's call that int. We can let's start at 0, and also because I need to get the maximum distance, so I need to have a variable to remember the maximum distance, and also so actually here I'm going to initialize into 1. I'm going to explain that a little bit. And also, I need to remember which seats have the, so let's call that answer. So which seats have achieved the maximum distance. So these two sort of goes together. The maximum distance is the maximum distance I can achieve, and this answer stores all the seats that can achieve the maximum distance. So so this answer initially, I didn't put any initializing value, so this will just create an empty vector. So right now we don't have any seed achieve this maximum distance. I put the distance 1 here because we want at least the distance of 1 between where I sit and the adjacent occupied seat. So if I find somewhere where I can sit only adjacently, the distance is 0, I don't even want to look at them. So because of that, I set the maximum distance is 1. So later, I will be looking at anytime if I see achieve a distance better, I'm going to update that. So then these are the sort of my state global, not global, my state variables for finding the solution. Now, starting from here, the first thing I want to find is I want to find the next which index give me the next one. So essentially, I want to find this guy. So I want to know if right now this is either this is empty or let's say if it is empty, then I want to find what's the first one in the array. Or if the first one is 0, then I know there's nothing here in the beginning. So I need to do that. I need to write that. I need to write the code to find that. And because I'm going to use that find function again and again, because after I find the 1, let me change this example again. I want to know where does the 1 end. And then I will start looking at the next sort of block of zeros, and the next block of 1, and so on. So that will be at high level my logic is. So I need this functionality of finding next. So I'm going to write a function to do that. So I'm going to write the two functions, find the next true value and the next next false value. And also I'm going to I want to find starting at some point what is the next value of that. So so this let's write what we want. It's sort of this function should return the index of the first true value starting from index I. So true value, and in fact we're going to use this seeds. Yeah. So how do we find it? So here I'm going to use a new type of loop called a while loop. So let's do the for version first, then do the I will show you the while loop since we okay. So we want to start, we start from I, and then we'll just keep incrementing I so long as this seeds I, if we want to find the first true, so if seeds I is false, we will keep going here, and then we will keep incrementing I. So here I actually use this for syntax where the initial part is empty. So because when I start, there's nothing for me to do. All I want to do is to check whether theta is if it's false, then I will increment I, and only when this is done, I will get out of the loop. At this point, I will just return I, because so then this code actually has a bug here. So if you don't immediately see it, I suggest you pause and then think about it, try to find it yourself. So the bug is this may actually, while we keep incrementing I, we may actually exceed the value we have. So we actually need we actually need to know the size of how many elements there are. So we actually, this n need to be made globally available. So in fact, because if I have an n declared inside the main function, it's only visible to the code inside the main function. I cannot use that n value in this next true function. So so I declare n here. And one thing that's dangerous, that kind of source of bugs that are a little difficult to find, is you have both n declared there and the n declared here. Then you would think you have put in n value here, this n, and this n are the same, but they are not. So you can have, so variable have scopes. So these n have a scope inside main. That n has a scope of over the whole file, over all the function in this file. And if you have a n here, it will hide the one outside. So when any n you refer within the main function, it will only use this n, but not that n. So the reason this kind of bug is difficult to find is if you had it in the first place, you didn't really think about the scoping. So you think about all the other logical issues, but they're not the source of the problem. Oftentimes, you really have to sort of keep debugging, printing out a lot of information before you realize, hey, actually, when I access n, they are not getting the value here. And also, C++ have this. If I just have n here without any initial value, there's no guarantee what value it is. So this value is kind of a little bit random. So then they will cause kind of random behavior. So then it's really it's making it even more difficult to debug. So considering that, actually, I think it's a better idea to initialize it to 0 and then get rid of it from here. Okay. So yeah, so the bug here, I need to make sure that seat I actually refer to something meaningful. So I put the condition here. So while I is less than n and seat I is false, I will keep incrementing I, and then I will return I. So yeah, this may look a little bit unfamiliar because I use a for statement, but the body is empty, and also this initial statement is empty. So when in that case, oftentimes it's more natural to use another way of writing the loop known as a while loop. So this is it's exactly equivalent. So we put the condition here. So essentially, while loop, we will first check the condition, and so long as the condition is true, we will keep doing the body, and the body is simply I++. So this is an equivalent version, and in fact, there's even more. There's also another equivalent version, which I guess it's really more kind of people who are more. I can do this. So okay, because here what I will do is I will increment I. But I will use this current I value before increment to reference the array index and check whether this is false. And yeah, so if it turns out this is no, actually, I'm not sure this is equivalent. Yeah, that's actually wrong. So because if the I is true, it will break, but the I will be incremented. So, and another thing that need to be that I should explain is this double AND have this behavior known as a short circuit. So what it means is that it will first check check this condition, I less than n. If that condition is true, then it will go on to check the second part. If that condition is false, then because we already know the overall result has to be false because this is logical n. So if the first thing is false, then no matter whether the second thing is true or false, it will always be false. So we actually don't check the second one. So then this is good because this guarantees that we will never reference seats n. So long as if I is equals n, then we will not even go here. So then my code will be correct. I don't reference something that I shouldn't. So this is known as the short circuit behavior. Okay, so much for this next true. Actually, let's take a break. Otherwise, I think this video will get too long. So let's return to this.